Okay, we are recording. For starters, if you don't mind, give me your name, spelling of your name, and the title you'd like to see on the air.
So my name is Jennifer McKinnon. It's MacKinnon, and I am a professor of oceanography at the Scripps Institution of Oceanography, University of California, San Diego.
Great. And you actually went to the Arctic to study why the ice there is melting.
I did. I've been there a couple times. The most recent time was for about a month in September of 2018.
Now, can you tell me, that the title you're giving this new, I guess, not phenomena, but you've discovered what is actually making the ice melt there?
Yeah, so the feature we've been looking at has different names depending on who you ask. The heat bombs name is sort of a colloquial, informal way of referring to these features. These are pockets of warm water that lurk subsurface in the Arctic. They're coming in from the Pacific Ocean through Bering Strait into that part of the Arctic Ocean. And as they arrive, because they are a little saltier than the surface water in the Arctic, which is fairly fresh, even though they're warmer, they can dive beneath the surface. They carry a lot of heat with them. They're able to swirl fairly far north into the Arctic, bringing a lot of heat deep into the Arctic and melting the ice from below. So these features have been seen for a little while, on and off for the last decade or so. But our contribution in the paper that comes out this week, I think, has really helped us understand how they work, how they get there, what makes them, and kind of what controls how much heat is coming into the Arctic this way and accelerating the sea ice melt.
Please tell me about the process of getting there for your research and the type of equipment that you use there.
So getting there, getting to the Arctic is still no easy task. So we take a series of flights to get to Nome, Alaska, which is a small town on the west coast of Alaska. It's where the Iditarod ends, and the home of the story about Balto the dog, which is a children, is popular as a children's book and very popular locally as a hero story. We typically take a ship, which is the research vessel Sekuliak, run by the University of Alaska, and it takes about 3 days on the ship to get all the way into the Arctic. So it's quite an ordeal to get there, and then we stay for about a month. If you're going all that way, you might as well stay for a while, living on the ship, working on the ship. We work 24/7, round the clock, day in and day out, weekdays, weekends, all the time. It's hard work. These aren't, luxury cruise ships. They're working science ships, but so it's a phenomenal opportunity to be there, and one I feel incredibly privileged to be able to be in places like that and do this sort of research. So you asked about tools.
Yeah, one of the things that I noticed in the video is a metal capsule of some sort that you put beneath the water.
Yeah, so we build many of our tools here in our lab at Scripps. So we have a dedicated team of amazing engineering talent that builds a lot of these instruments from scratch. And we have found that if you want to see the world around us, and particularly the ocean, in new ways and see things that people haven't seen before and get insights into how the world around us works, you often need new tools to be able to see the world in different ways. And so the tools that our group makes allow us to see subsurface in the ocean with greater resolution and detail than most previous measurements have allowed. And a lot of the processes that are mediating how this heat comes in are really intricate and complicated. And if you don't see them clearly, you can't understand them. And so our tools allow us to very rapidly sample from a ship. So we have a fast winch that allows this instrument that measures temperature, salinity, some biological properties of the ocean to go up and down really rapidly as we move the ship around. And so we can identify features, these subsurface heat pockets, and see them in really great detail.
If you could explain in a little more detail what you're describing as a heat bomb and how this works.
So the Arctic, like most oceans, has different layers in it. So the surface water is really cold and fresh. It's where the sea ice lives. So if you look at the ocean from a satellite, you see the surface as near freezing temperature almost everywhere in the Arctic much of the year. Um, but this water coming in from the Pacific, it is warmer and saltier. And as this current comes in, it comes in through Bering Strait. It flows through this very constrained channel called Barrow Canyon, which is on the northwestern tip of Alaska. And as that current meanders around, it spits off these little blobs, these little heat bombs, which pinch off from this meandering river of warm water. And they pinch off and they dive beneath the surface and they sort of ooze out into the central Arctic. And that process of how you get these boluses of heat pinching off from a current is the part that we were really excited to study and understand. And that helps us understand and predict how much heat is entering through this type of mechanism.
How serious is the possibility, of us losing all the ice there in the Arctic?
So it seems quite likely that all of the ice in the summer will be gone in the not too distant future in the next decade or two. There will still be ice in the winter, but the year-round ice won't be there. And so that is significant for a number of reasons and quite disturbing. One is that if you just have seasonal ice, so it freezes in the winter and melts in the summer, it doesn't get very thick. The ice that lasts for multiple years tends to be much thicker. It plays a different role in the climate. It provides a different type of environment for the ecology of the Arctic, the polar bears, the walruses, et cetera. So losing the year-round ice has huge implications for the ecology, for the indigenous communities living around the Arctic, for the global climate, for all sorts of operations, commercial operations in the Arctic, naval operations in the Arctic. There's very wide-ranging implications, which are pretty dramatic.
I mean, that even affects our weather here in San Diego, right?
Oh, for sure. Yeah, and so there's a number of ways that it does. One is just that the whole climate is interconnected, and the Arctic Ocean is a bit of a canary in the coal mine, and it's changing in ways that not only preview how the rest of the world changes, but it influences other weather. One of the ways that's been in the news recently is that it seems as though when you change the temperature difference between kind of the warmer temperatures we have in the lower 48 and the colder temperatures of the Arctic, as the Arctic Ocean warms and the atmosphere above it warms, as that temperature difference changes, you start to get more meandering of the jet stream, and you get these Arctic vortexes coming down, which have been dramatic features in US weather recently. And so it's all connected. It seems very far away, but from those weather pattern perspectives, it's not really.
As somebody who lived and worked in that area for a while, can you describe to us here in San Diego? I mean, I myself, we don't have the appreciation for actually seeing polar bears and sea life there. Can you tell me about some of your observations there?
Yeah, I mean, it's amazing. It is such a privilege to be able to work in such a pristine and beautiful place. We try to not get too close to those animals, to be respectful of them and their environment, but we see them in the distance, and there are walruses and polar bears, and there's whales, and really a unique ecosystem from kind of the microbial level on up. It's a totally unique and in some ways otherworldly place. It feels very far removed in some ways from regular life, in a busy city like this, to be in it's very quiet, it's very cold, it's really beautiful. The northern lights come out at night. It's amazing. But we're also very aware while we're there that the things we're studying and the way that it's changing are very dramatic, not only for the Arctic, but are so interconnected that it's not actually as far away as it seems.
Yeah, kind of tragic that these animals are going to be hurt in the long run by the loss of this ice.
Yeah, I mean, the animals their whole world will change. We're also trying to be very respectful of the native communities and indigenous communities that line all the way around the Arctic, because their way of life is based in some part on those ecosystems, and is going to be dramatically changing as well.
So now with the new knowledge that you've gained from your research there of these, so-called heat bombs, what next? What happens now?
Well, now that we feel like we as a community, I mean, science is an incredibly collaborative enterprise, which is one of the reasons I really like it. So there's a wonderful group of people from nations all over the world working on these issues, and just our group involved collaborators from the U.S. and the United Kingdom and Germany. We work closely with colleagues in Canada. Anyway, the whole scientific community is trying to think about what we do with this knowledge. And the first obvious step is just to improve our forecast models, improve our forecasts of what's likely to happen. That if we have a better prediction for how the Arctic is changing, how the global climate will change in response, we can prepare, we can adapt, we can adjust, we can at least know what's coming our way.
Pretty phenomenal. Anything else that you want to leave our viewers with about your research and what you learned?
No, I guess, I often I talk to my kids' classes sometimes, and I think people often have this view of science that it's sort of stodgy, or it's, people are working on problems in a certain way, and it's so exciting to do this type of work. We don't know what we're going to see. We discover things like this. You figure them out as you go along. It's creative, it's exploratory, it's a community collaborative effort. It's a wonderful it's a wonderful thing to do that I feel very privileged to do. And I would certainly encourage lots of people to get involved in science any way they can.
Thank you so much for talking with us. Appreciate it.
Yeah, of course.